الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين، والصلاة والسلام الأتمان الأكملان على خاتم النبيين رسول الله إلى الناس أجمعين محمد بن عبد الله وعلى آله وصحبه والتابعين ومن تبعهم بإحسان إلى يوم الدين. أما بعد، فالسلام عليكم ورحمة الله وبركاته. المحاضرة التي ستشاهدونها بعد قليل هي محاضرة عن العلوم الطبيعية والغيبيات، وفيها نحاول إظهار أن العلوم الطبيعية إذا درست وتفكر فيها تهدي إلى وجود الخالق العظيم جل جلاله. فنحن نعرف الله سبحانه وتعالى بما علمنا القرآن وعلمتنا السنة، وكذلك نتعرف على الله سبحانه وتعالى من التفكر في بديع خلقه. ففي الإسلام لا تنافي بين العلوم الطبيعية وبين الكتاب والسنة، بل هم آيات يهدون إلى الله سبحانه وتعالى. في الغرب كانت الكنيسة دائما تضاد العلوم الطبيعية، بينما الإسلام يحض على التفكر، ولذلك كان المسلمون هم أول من وضعوا أسس العلوم الطبيعية كما نعلمها اليوم. أسأل الله سبحانه وتعالى أن يوفقني وإياكم إلى فعل الخير والدلالة عليه ودعمه بكل ما نستطيع، فإن العالم في حاجة ماسة لمن يهديهم سواء السبيل. اللهم اجعلنا وإياكم هداة مهتدين، لا ضالين ولا مضلين، مفاتح لكل خير، مغالق لكل شر. جزاكم الله خيرا، والسلام عليكم ورحمة الله وبركاته.
والصلاة والسلام على سيد المرسلين محمد وعلى آله وأصحابه أجمعين. إن الله وملائكته يصلون على النبي يا أيها الذين آمنوا صلوا عليه وسلموا تسليما. اللهم صل على سيدنا ونبينا ومولانا محمد وعلى آل سيدنا ونبينا ومولانا محمد وبارك وسلم. Highly respected and honored guest, Sheikh Muhammad A Al-Akkas, and respected friends, brothers and sisters. Once again, we have this opportunity to be in the midst of a person with tremendous knowledge and experience in terms of da'wah and being active, who I think, and this is my assumption, I don't mean the Sheikh looks old, but maybe in terms of age, maybe just one or two might match him, maybe Musa and somebody, you know. We young, what we need to learn is being young. Yeah? We need to be more active. MashaAllah, at this age, although Sheikh is not here to study, but he's got this zeal inside him that he wants to do something Islamic for the purpose of da'wah, to promote our deen, to strengthen our iman. Yeah? And this is something that we should have a zeal to do as well, especially being young, full of energy, great ideas in our minds, time at our disposal as well, maybe limited due to our educational commitments. But I personally, and I repeat this over and over again in my Jummah sessions, that we need to be active, we need to be involved, we need to engage. And may Allah give us the tawfiq to do so and learn from the Sheikh. at this age. Not very old yet. But mashallah, in terms of spirituality, young, zeal, young, and which is what we all are in the need of. We're lucky that Sheikh is with us, not only for today's session, or this month or this year, but inshallah for approximately 3 years. Yeah. Sheikh's educational background is he have experience and qualifications in electrical engineering, computer science, and business management, as well as the educational qualifications that he had and he has equipped himself with and he has attained. Around the world he has been traveling due to work commitments, working with various organizations like Aramco, the Saudi oil company, IBM, etc., etc. And no doubt that that also develops a person, coming in contact with people from different cultures, background, nations, etc., etc. And in his homeland, Saudi Arabia, he is either a board member or a founder and director of some of these well-known Islamic Dawah centers and departments in places like Dammam and Al-Khobar. And there are many courses which he has been influential in developing, designing, and in the delivery. And one example would be the cultural awareness course, which was developed and designed under his management and instructions for the cultural awareness of the armed forces, and mainly the armed forces of USA at the time of the Gulf War. And if I'm not wrong, was it 7,500 from amongst the armed forces who accepted Islam through this one cultural awareness course. Yeah? He was also very influential and instrumental in the chaplain endorsement program. So he has a vast experience in terms of da'wah, working with government officials, high-profile companies, and university students. His daughter is also a Salfordian, a student at the University of Salford, which is the reason and cause why the Sheikh will be with us here for 3 years to accompany his daughter who is studying here. So this will be the first of, inshallah, many programs. And let me remind you that throughout the week, is it Tuesdays, Wednesdays, and Saturdays, Sunday after Maghrib Salat, after Isha Salat, that the Sheikh delivers lectures and sessions, which I would like to invite you to and try to encourage others to invite. And we're lucky, we're fortunate that we have a student society, Islamic society, who have arranged this program, who care for you, who are concerned. We need to be with them, we need to support them, and the good work that they are doing, we need to promote it as much as possible. May Allah give us ikhlas, which is sincerity. May Allah enable us to take effect from what we hear, and may Allah enable us to internalize the message. And finally, I would like to thank Sheikh as well for being with us and to stay with us and to be with us, inshallah, in a role and a manner where he can instruct and guide us. Wa jazakumullahu khair. I will leave the mic with the Sheikh, inshallah. Jazakumullahu khair.
Alhamdulillahi Rabbil Alameen. الرحمن الرحيم مالك يوم الدين والصلاة والسلام الأتمان الأكملان على خاتم النبيين رسول الله إلى الناس أجمعين محمد بن عبد الله وعلى آله وصحبه والتابعين ومن تبعهم بإحسان إلى يوم الدين. أما بعد، السلام عليكم ورحمة الله وبركاته. As for age, I am only older than 20. So I don't know about Sheikh Rashid, what impression, but certainly I'm over 20 years old. And you can count from there any number you want. And it depends on your impression, how old or not I am. Today we will be talking about science and the unseen. Sometimes we are led to the impression that these two things do not come together. They are two different venues. We will be talking about this, inshallah. And I will be talking about some things that might be, something you know better than I. But from my experience, when I learned English, they stepped back a little bit from where we knew, and they built on. And that enabled us to better understand or learn English. It's a good idea to not assume too much and to go back to where you have certainty that you can build on. If you assume a little too much as a teacher, you tend to leave students behind who missed one thing. I remember one friend of mine, he used to take a course and drop it. That was chemistry. Because he always arrived 1 or 2 days late, or 1 or 2 sessions late. And by that time, the teacher started talking about molality and molecular weight and the mole and so on. And he never had the courage to ask or to go and search what a mole is. And eventually he felt like lost in that course. He dropped it. And he tried it another time. And he dropped it. He did the same mistake. Third time, he came early, and the teacher was defining what a mole is. What is a mole? Come on, tell me. Huh? Nobody has chemistry courses here? The Avogadro's number of particles. That is a mole of that particles. Yeah? Huh? Yeah, that's the number. But that is 6.23 is to the power what? Times 10 to the power 23. That is defined as Avogadro's number. So it was a basic definition that if the teacher repeated more than once, my friend would not have had to drop the course twice before he continued the third time. So I might be talking about things that are fundamental to you. If you happen to see that something is not clear, stop me. You can interrupt me anytime. I don't mind being interrupted. I do not have something that I memorize and I have to spit out and finish with. No. The idea is for us to learn together, right? So you can interrupt me, and you can ask questions, and you can even differ with what I am saying and tell me your idea. No problem. Understand that? Okay, very well. So let's start, inshallah. What is science? I know it is a basic question, but the definition that the Science Council gave is science is the pursuit and application of knowledge and understanding of the natural and social world following a systematic methodology based on evidence. Right? During the Islamic Golden Age, the foundation for the scientific method was laid, which emphasized experimental data and reproducibility of its results. In the West, during the early modern period, the world science and philosophy of nature were sometimes used interchangeably. It is not until the 17th century natural philosophy, which is to study, which is today called natural science, was considered a separate branch of philosophy. That's why we say PhD, even if it has nothing to do with philosophy. The term science has also continued to be used in a broad sense to denote reliable and teachable knowledge about a topic. In that sense, science overlaps with art. Art is the expression and application of human creative skill and imagination, typically in a visual form such as painting or sculpture, producing works to be appreciated primarily for their beauty or emotional power. Well, you may have seen this or you may relate to it. The earth without art is just yeah. So art we like, since we are talking about science, we should not undermine art, because some engineers would build you a building, functional building, but it looks ugly because there is no art in it. We need art to deliver scientific or technological product. So science and religion. Events in Europe such as the Galileo affair, associated with the scientific revolution and the age of enlightenment, led scholars such as John Williams Dropper to postulate a conflict thesis, holding that religion and science conflict methodologically, factually, and politically. This thesis is advanced by contemporary scientists such as Richard Dawkins, Steven Weinberg, and Carl Sagan. That's why you see that we separate science and religion are totally separate issues in a country like this one. Many theologians, philosophers, and scientists in history have found no conflict between their faith and science. Biologist Stephen Jay Gould, biologist Stephen Jay Gould, other scientists, and some contemporary theologians hold that religion and science are non-overlapping magistria, addressing fundamentally separate forms of knowledge and aspect of life. You see, there is no conflict, but basically, you keep yours, I keep mine. Yeah? So it's not that there is no conflict if there is no overlap to two different issues. And so therefore, in the West, scientists and theologians see science and religion as either incompatible, conflicting, independent, or parallels. Nowadays, because of this creates problems for people who have religious tendencies, but at the same time they want to believe in science. You have to believe in science, right? And therefore there is a non-denominational group or groups that promote dialogue between the two. When you say dialogue, that means two different things, but try to have a bridge between the two areas. In the West, it sounds like when it is spoken of religion, Christianity is meant more specifically. Yeah? whenever they say here religion, they mean Christianity. And so religion is that, religion is that. Whatever they say, mostly they are speaking about Christianity, although they use the word religion instead of saying only religion. From the above, it is probably why we see in the West the tendency for not having a room for spiritual concepts on the seats of School of Science. In Islam, however, we learn about the Almighty God, Allah subhanahu wa ta'ala, by studying the Quran, the Sunnah, and by pondering and investigating how this universe is put together. Let us see how. Scientific methodology. According to most historians, the modern scientific method was first developed by Islamic scientists, pioneered by Ibn al-Haytham, known to the West as Al-Hazan. Robert Briffault, in The Making of Humanity, asserts that the very existence of science, as it is understood in the modern sense, is rooted in the scientific thought and knowledge that emerged in Islamic civilization during that time. Nowadays, people want to ascribe, all science and advance only to the West, but the West is dependent on on Islamic finding. For example, let me tell you, zero. Who invented zero? If you look at a clock using Roman numbers, then you will find I 1, double I 2, triple I 3, V and I before it 4, V alone is 5, V and an I 6, double I 7, triple I 8, X minus one with an I before it 10, X is 10. But tell me how you will be saying a million or writing a million in Roman numbers. How would your telephones and computers would work without zero? But in Arabic, numbers, as are said told in the dictionary, numbers are 1 angle, 2 angles, 3 angles, 4 angles, and then 9 angles. We can draw them if you want, but no angle is the circle, 0 angles. So it is sad today that you hear some Arabs saying 1 0 2. You should say صفر, not 0, right? So 0 is invented by the Arabs, and without that, by the Muslims, and without the 0 we would not have computers. Nothing digital today. Scientific methodology includes the following: objective observation, and that is measurement and data, possibly, although not necessarily using mathematics as a tool; evidence, experiment and or observation as benchmarks for testing hypotheses; induction, reasoning to establish general rules for or conclusion drawn from facts or examples; repetition, critical analysis, verification and testing; critical exposure to scrutiny, peer review and assessment. Induction is one thing we want to stop at for a moment, because that is how we as Muslims use the finding we see in nature. We use it in an inductive manner, in a projecting manner, to learn about the unseen. Induction is an important tool for us to, like sit here like to establish general rules. We cannot have all the data we want, but we have a small amount of data, and then from that data we draw a trend. We will find a trend, and from that trend we will what? We will make a general rule, right? You understand what I'm saying? You know, when you draw a curve, and then you can extend the curve and say, okay, at such and such x, we will have y. So reflections on some of aspects of biochemistry. We'll talk about some biochemistry that would lead us to, hopefully that will not lose me or you. Proteins are the body's worker molecules. They are in your hair and nails, in your muscles. They are on your blood, on your brain and nerves. They are they are the cellular messengers. We find them they are enzymes, antibodies, cellular construction workers. We find protein everywhere. Actually, proteins are made out of amino acids. Amino acids are biologically important organic compounds composed of amine, NH2, and carboxylic. Excuse me if I mispronounce some of these. Carboxylic acid, which is COH. Functional groups, these two functional groups, along with the side chain specific to each amino acid. The key elements of an amino acid are carbon, hydrogen, oxygen, and nitrogen, though other elements are found in the side chain of certain amino acids. There are about 500 amino acids that are known and can be classified in many ways. They can be classified according to the core structure, functional group, location, functional group's location as alpha, beta, delta amino acids. In the form of proteins, amino acids comprise the second largest component after water of the human body. This is what this diagram is what is known as the backbone of amino acids. We have the amine to the left, and we have the carboxylic acid to the right. And in between, there is a linking atom, which is the carbon. And so that's called the alpha carbon amino acid. The chain that is that is represented here by R varies from one amino acid to the other. The basic is the same, but the R changes, and that's what gives us the different amino acids. About 500, some say more than 500. But from these 500, we find that there are 23 alpha amino acids. Alpha meaning the carbon is being attachment is called alpha. Only 21 of them are considered to be standard amino acids decoded or that can be coded or decoded by DNA. The amino acids in a protein are joined together by the peptides bound. Peptide meaning that the connection, the electrons are shared between atoms. The sequence of amino acids in a protein is defined by the sequence of a gene which is encoded in the genetic code. This is how an amino acid is combined. This combination is called the condensation combination, because two amino acids come together, they join on the right bond, right, and they produce two molecules of 2 molecules of water. That's why, hence the word condensation. An average protein size is about 200 to 550 amino acids. In humans, the median protein length is roughly 350 amino acids, and the mean is 476. Titan, on the other hand, is 34,350 amino acids long. This diagram shows you what we mean by the distribution, the mean and the average and so on, right? Amino acids are therefore 20 different amino acids, either left-handed or right-handed, and peptide or bond or non-peptide bond. Assuming controlled environment, like in a lab, we can calculate the probability of getting a viable protein by chance as follows. Just by the way, recently, like in this diagram here, you will find that they are 21. But most biology books will tell you they are 20 amino acids. Let us take an average size protein, such as commonly found Robisco or ATP, consisting of about 550 amino acids. Then the chance that we would select the right amino acid, we said there are 20, the chance that we will select the right amino acid every time we want to pick one would be 1 over 20. When we should repeat that 550 times for that protein. Therefore, the probability of picking all the amino acids correctly for our 550 amino acid protein would be 1 in 10 to the power 715. And for those who want to look at the calculation, that's how it is calculated. 1 over 2, I should have changed this to 20. The log of 1 over 20 to the power 550 is equals 550 log 1 over 20, and by calculation it becomes 1 over 10 to the power 715. Protein required for your cells to develop its energy. Again, using the same argument, we have the right-handed, we need to pick right-handed amino acid connection. So it is either left or right. So if we want to pick, it's a chance of 1 into 2. And if we repeat for 550, it would be 1 chance in 10 to the power 165. Again, the calculation is such. All right? And again, is it peptide or not peptide? If it is peptide, we have a chance of 1/2, 1 in 2, and the calculation again will give us the same kind of arrangement, same calculation. So therefore, if we the probability of doing all the right amino acid, right-handed, and peptide bond, if we all of this combination, it is this times that, and it will equal to, you add the powers as you know, and when you multiply numbers, the power is added, so it's the power is 10 to the power 10 to the power 1045. All right, and if you want to draw a picture of what that number looks like, it is one chance into 1 with 1045 zeros in front of it. Now, if we say, what is the probability for 30? I mean, maybe you picked 550 and that is a huge number. Why didn't you choose a small amino acid? Or a small, rather, protein? Well, the smallest that is found in nature is 30 amino acids. And second smallest is 50. Right? And if we calculate for 30, we will find that it is one chance in 10 to the power 57. And for 50, it is one chance in 10 to the power 95. But scientists consider anything less than one chance in 10 to the power 50 is zero. From what we have seen, quickly we will go over this. For us to make a protein of 550 amino acids, we need to pick the right amino acid out of 20, one of the 20, and we need to pick the fact that they are attached to each other using the right-handedly, or the right-hand side, and also that they are peptide kind of connection instead of the non-peptide. All right? And if we do that, then just for picking the right amino acid, the chance would be 1 in 10 to the power 715. A very, very slim chance. But that is, remember, it is assuming lab environment, not a hostile environment where these things are coming together, but lab environment, controlled environment. Yes, sir. You had a question.
Yes, sir. Is it the probability of making, like having a protein?
It is, if I were to go into the lab and I have 20 different amino acids, enough of them, and I want to pick by chance, just rolling and picking the right amino acid. They are not all one type. In one protein, there are several types of amino acids. So I want to pick the right one at the right time. Yes? So picking one out of 20, the chance is 1 in 20, because they are 20. One of these 20, any one of them may come out. And then I have to repeat that 550 times. The chance for me to do all of that consistently correct is so slim, it is only 1 in to the 10 power to the power 715, assuming 550 amino acids in one protein. Do you get my point? Is that
the probability of having the right protein, right?
The right protein and the right amino acids for that protein.
So that's to say the probability of forming a protein.
Forming a protein of 500, forming a given protein that contains 550 amino acids. And if I go into the right-handed versus left-handed, the chance is 1 in 2, and again for 550 times it will take, the chance would be only 1 in to 10 to to the power 165. Again, assuming what? What is the assumption? The environment is what? Lab environment, not hostile environment, not you do and then the environment breaks down. No, assuming that whatever you put together stays together until you pick the right one. But that is not the normal state. The normal state is that whatever happens, connection may break before you pick the other one. So the probability would be that much higher. But still, assuming the lab environment, it is a very, very slim chance. And again, for the peptide versus non-peptide, so for the probability for all of these things to happen together is the multiplication of these, as you know in your probability and statistics courses, and that would mean the sum of the powers, right? And that would be 10 to the power 1 chance in 10 to the power 1045. And written in like this is the number. This is how you would write the number down. And there is something I did not mention earlier, but I should remind you that proteins are not, they are strings of amino acids, but there is something important for them. They have to be folded. And it is that folding that is still mysterious to the scientists as how that folding takes place. Besides arranging them, besides making the string, it's folding them, folding that amino acid, sets of amino acids to take the form of the, for example, the protein is measured in close to 1 nanometer. The length of a protein is close to 1 nanometer. You know what a nanometer is? 10 to the power minus 9 of a meter. So that is the length of what? One protein. And the largest, which we will come to, we mentioned it, the largest is 1 micrometer, 1 millionth of a meter. That's the largest protein. So still that is folded. So, subhanallah, it is so dense and so complicated. The folding, until now, scientists did not come to a decision as how that happens anyway. Now, picking a 550 amino acid, which is common, like I said, the ATP is the protein needed to generate the energy and power in every cell, right? It is the shield of the cell, and it is the means by which that cell gets its energy from the food, right? That ATP is so common, therefore, and its size is 550. But even if I were to take the only 30 or 50 amino acids, the chance would be for it to happen by chance in the lab is 0. Right? Now, Professor Robert Shapiro of the New York University calculated the chance for the formation of a single bacteria containing 2,000 types of amino acids to be 1 in 10 to the power 40,000. There are, conversely, in relative, comparing that, in a human being, the cell may be comprised of 200,000 amino acids. And so the chance is very huge, one in a very huge number, absolutely 0. There is no chance. In the in the human being there is a titin, there is a protein called titin. And the titin is a protein that is made of 34,350 amino acids. Right? For that to happen by chance would be 1 in 10 to the power 50 to 600, what is it? 65,265. But titin is interesting because the mouse variant of that same protein is larger than that of the human, 35,213. So by evolution, we human being went into evolution to become what? Mices. Yeah, which is, think about it. You made a huge protein that is the state of the man. Now you need to make a bigger protein that will take evolution. If it took evolution, then we will all will become Mises instead of human beings. Yeah? Enzymes are huge proteins. But the reason I am showing this slide is actually how do I switch the light for a moment? Lights. I want you to read the footnote. The rate of acceleration conferred by synthesis enzymes catalyst is enormous. As such as 10 to the power 17. You know what a catalyst is? It is a chemical or something that helps accelerate the chemical reaction, right? But the enzymes accelerated something to the power 10 to the power 17 times. Yeah? And to put it in time scale, it is like 78 million years without the enzyme compared to 18 milliseconds with the enzyme. Now, is that by chance? Which one? Okay. Now, do you want it this way or that way? Okay. So, again, enzymes, just the presence of enzymes and the fact that enzymes are there and used in that manner points away from by chance. Well, having finished the statistics and finding it impossible to do that by chance, because it is, hit and miss arrangement, that is one thing. But for the arrangement to be done according to a code, that means must be by design. Code. Like the dictionary, if you were to take the characters of a full Oxford dictionary, throw them in the air, and then expect them to come together like what? Like Oxford dictionary. What is the possibility? It's not a matter of just making words, every few letters making a string, but you want to make something intellectual. Yeah? Something you can read. It's impossible because it has to follow a code. That is, T is different from 8, although they are of the same 3 letters, or eat. Right? So DNA and RNA are used to encode protein structure and synthesis. That means information-based structure and synthesis, not accidental. DNA and RNAs have been quite a setback for evolution theory. RNA is a single-stranded molecule in most of its biological roles and has a much shorter chain of nucleotide than DNA. RNA are less stable than DNA. I want you to think, if you don't know DNA and RNA, I want you to think of the DNA as a master plan. You know, we use in drawings, civil engineering and architecture, we use mylar. Mylar is a very thick and nice, good material for printing the drawings on, right? From that mylar, it's like the film. We would use it like a film to put it in a blueprint machine, and blueprints would be what? Produced. Those blueprints we send to the field, they get destroyed. We have the master on mylar. So DNA is the what? The mylar, the mylar, the master plan. And RNAs are like the blueprints. They copy what is in the DNA, go and do their work, and then they get destroyed. Right? So these are RNAs. RNA is central to protein synthesis. Here, a type of RNA called messenger. Messenger meaning bringing the information from the DNA to the work. It carries information like a blueprint from DNA to structures called ribosomes. These ribosomes are made from proteins and ribosomal RNAs, which come together to form a molecular machine that reads messenger RNAs and translate the information they carry into proteins. DNA, on the other hand, the main role of DNA molecules is the long-term storage of genetic information. DNA is often compared to a set of master prints, like I said, like a recipe or a code, since it contains the instructions needed to construct other components of cell, such as protein. In living organisms, DNA does not as usually exist as a single molecule, but rather instead as a pair of molecules that are held tightly together. These two long strands intertwine like vines in the shape of a double helix. DNA consists of two long polymers of simple units with a backbone, with backbones made of sugars and phosphate groups joined by ester bonds. Attached to each sugar is one of four types of molecules called bases. It is the sequence of these four codes along the backbone that encodes information. DNA is made from repeating units called nucleotides. For instance, the largest human chromosome number 1, is approximately 220 million base pairs long. 220 million base pairs. Now, what happens to the DNA? It opens up into two parts. One part becomes the master, because we said there are two strings intertwined together. One part becomes the master, the other one becomes the transmitter. It's copied. The RNA copies one of them and follows the master to reproduce. This is a schematic. Schematic A to the left model, a schematic model of the double helix. One turn of the helix is about 3.4 nanometer. One turn meaning from this point here to this point here. Same if you were to turn 360 degrees, where that point would go back. That turn is 3.4 nanometer, and it would contain about 10 base pairs in that 3.4 nanometer. On the diagram on the right, B, space filling model of the double helix. The sugar and phosphate are residues in each strand from the backbone, which are traced by the yellow, the gray, and the red circles. Show the helix twist of the overall molecule. The bases project inward, but are accessible through major and minor grooves. The bases are the blue ones. This is that is the filling, right? Is this clear? Okay, so it is information-based manufacturing. Therefore, to produce a protein, the DNA is copied into messenger RNAs. Also, ribosomal RNAs are made. The ribosomal RNAs are combined with proteins to produce ribosomes. These combinations are used along with the messenger RNAs to manufacture new proteins. It is an information-based process. Information. Therefore, it is not haphazard selection. For something to evolve after that, for something to evolve, it must have a starting point. The question therefore is, how did that starting point exist? You know, when they talk about evolution, they tell you that something became something else. Well, what that something itself? How did it occur? From where? How did it exist in itself? Yeah? Well, an atheist professor or said to a student, "Give me some dust and water, I will create for you a bird." The student said, "What? Why don't you make your own dust and water? If you are that clever, why start from something that is made by other than you? Make your own from zero." And that is what people do not ask when they talk about evolution. They do not ask about the starting point, sadly. Well, for living, we finished with the statistics, probability and statistics. We went into the information coding, right? And then we go back to, for living things, for you and I. Not only do they have to exist physically, but they must also acquire life, something that is not addressed by biology, evolution. These two birds, one to the left is living. Suppose it's the same bird, because I do not have the same picture of the same bird dead. But supposing the other bird to the right is the dead bird, the same bird dead, physically, they are 100% the same. Right? But what is missing from the right that was in the left? Life. What is life? Conclusively, therefore, and on a logical and scientific basis, this universe must have come into existence by design. There must have been a creator who has determined to make it into existence. To remove the confusion between science and the unseen, let's consider the following illustration. Really, matter we will represent by the set M, the green set. Therefore, when we talk about matter, we tend to use exact terms and language. What is water? 2 atoms of hydrogen, 1 atom of oxygen. The hydrogen is such and such specifications, and the oxygen such and such. Very clear, right? How they are combined. We use exact terms and language. We speak of what it is, not how it came or how it happens, but what it is as a matter of fact. And we describe and predict how it behaves. This is when it is matter. Set E, let's consider that includes reflexes, hope, attitude, feelings, emotions, ego, beliefs, intellect, imagination, fear, courage, shame, honor, intention, love, hate, pleasure, anger, anxiety, tranquility, trust, fear, and so on, of the same, right? These are not the scope of, strictly the scope of science, but maybe the scope of art. Therefore, when we talk about these issues, we tend to use approximate terms and language, not exact. We tend to describe or predict how it happens and may behave, how it happens and may behave, and be ambiguous and confused about what in essence it really is. If I say, I know, if I tell you, such and such building is at that intersection, you say, I know. What does I know mean? What it is that I know is, we don't know. I know, I just know. What is knowing? What is love? What is hate? What is fear? What is confidence? All of these are terms that are not describable as what they are. Maybe how they happen. Yeah? Furthermore, set S, angels, spirit, soul, self, life, conscious, judgment day, paradise, hellfire, etc., life in the grave. Yeah? This is beyond science. Therefore, when we talk about about issues of set S, we soon realize that they are issues of the unseen. We must relate to them only in terms of what the religious sources tell us. We don't have any access to them, that information. Yeah? What is a human being? Let's call a human being set H. And H would be a set that intersects all the 3 previous sets. Set M, set E, and set S. Why? Because a human being is made of matter, my body, made of feelings, hopefully I have some, and made of soul, self, spirit, right? And therefore, it shares characteristics of all 3. That's what it means when we studied sets and subsets are when they intersect, meaning they share some, the area of the intersection shares some of the characteristics of the other 3 sets. In this case, 3 sets. Therefore, when we talk about human beings, we must realize that we are talking about a very complex being. We did not yet master the materialistic side of its characteristics, and we are barely scratching the surface of its other characteristics. That's why I consider medicine to be more of, has so much art, not pure science. And medicine is coming to realize that. And nowadays, we do not only talk about, what is called as La ilaha illallah. We're not about curative medicine. We don't talk only about curative medicine, but we talk about other medicines. The healing of the spirit, the healing, the encouragement of the patient. We talk to the patient and say to him or her that yes, he will be able to go through this operation well and so forth. That willpower pushed into that human being tends to help during what? Going through traumas such as a very difficult operation. That is not curative. It's not, antibiotic or painkiller. Yes, but it is something with the encouragement, hope. There was a lady who was, long-term captive to the white linen in the hospital, and loads of medicine was given to her, so many of them. The nurse was kind of caring, so she talked to that woman and realized that old lady had a daughter, one only child, but that has not seen for a long time. So the nurse, went searching until she found that daughter and asked that daughter to please come and see her mama. That daughter came and saw mama, and all of that list of medicine was thrown in the bin. The mama was cured. All she needed is to see her child. Can think about what is it, how much influence you have when you allow your parents to see you, to touch you, to feel you. We tend to deal with our parents nowadays on mechanical approach and mechanical almost only. Sad, isn't it? So if we put all of this into one set, we call it what? Creation. The creator, represented here by a set, but greater than that, but for us to understand, Allah Almighty, in the Bible it is called Eli or Eloi or Allah, the one and only true God. By the way, Allah is a name. It's not to be translated into God, G-O-D. In the Semitic languages where even the Bible was written from, there is no capital and lowercase letters. They are all the same case. So there is no capital G, God, and small g, God. It's only God. Yeah? God is equal to Ilah. And Allah is a personal name. So it's not correct for us to translate the name into Khuda or Jos or whatever. Allah is a personal name that is not to be translated. Because if your name is Jamil, nobody will call you around and say to you, hello, beautiful. You may even look ugly, but your name is Jamil. Jamil means beautiful. Hello, Mr. Beautiful. Good morning, Mr. Beautiful. Good afternoon. Goodbye, Mr. Beautiful. Yeah? So, the one and only true God is the creator. He was the first without beginning. He was before any creation. He created everything from nothing, and he holds this creation intact. Allah, the one and only true God, He is the first without beginning. He is the last without end. He is the absolute. He does not need his creation. He was without his creation. He is the owner and king of all of the universe without any partner. He is not like his creation, and he cannot be contained by his creation. If God Almighty Allah cannot be contained by his creation, like the Bible says, "Oh God, how can I build you a temple when the whole heavens cannot contain you?" Yeah, this is to be found in the Bible. Now, therefore, can a womb contain God? You have to just think. Can a womb contain God? You know, a womb of a woman contain God? The answer is no, because the whole heavens cannot contain God. Right? People have to think, because sometimes we read only to confirm what we are believing without even thinking about what we are reading. But we should read to what? To learn and verify what we know. So therefore, you can say to anybody, you know, if you can imagine it, then it's not God. You cannot put a shape, an elephant with a man with an elephant head and say that's God. You cannot do whatever you make. If you can imagine it, it's not God, because God is beyond our imagination. Yes? No problem. No problem. Yes?
Just want to make comments about the statement you just read from the Bible. It says, can you say it again?
I said, God, how can I build you a temple when the whole heavens cannot contain you? God, how can I build you a temple, a house, when the whole heavens cannot contain you? Meaning I cannot make a big enough house for you to reside. Now, when we say something, the masjid is a house of God, house of Allah, that means, we call that in Arabic nisbah, to relate it to God, not that God lives there. Yeah, not only figurative. It is just saying like, something that associated with, not a place where God can be contained or housed. Yeah? So, creator and creation are two different sets. There is no intersection. Therefore, if we could not use, you see, if we use the logic of H onto E or onto S, no matter how scientifically sounding it may be, it is illogical. It's incorrect. Yeah, it's not. Do not be fooled by how impressive the expression may be. If I use the information of H onto, of M onto S, that is not scientific, illogical. You understand what I'm saying? You have to use the logic of S onto S, and M onto M, and E onto E, and do not, because they do not intersect, do not mix them up. Only H shares some of M and some of E and some of S. Therefore, we will find, talking about H, aspects of M, E, and S. So, creation and creator even further. If S is beyond science, then creator is way beyond science. But like I said earlier, we use science as what? By induction, we use science to recognize who the creator is. Right? So, From this, we conclude that the universe of ours is created. The creator, therefore, must be infinitely knowledgeable, infinitely wise, infinitely able, and infinitely merciful, powerful. Indeed, Alhamdulillah Rabbil Alameen. 4, 5, okay. If we reflect on how Allah subhanahu wa ta'ala created the universe and what He provided us, we also conclude that He is infinitely kind and merciful, infinitely generous and infinitely forgiving. Imagine, just imagine that I could not predict, I don't know how many tons of concrete above us. And you could be in a high-rise building and you walk into the lobby of that building, not worried that it will collapse, thousands of tons of concrete above your head. But you, because Allah subhanahu wa ta'ala made it possible for us to predict how much these columns are going to carry, yeah, we walk into the lobby of that building feeling okay. We walk in the streets. If earth was not well established, I know that I can walk without being, sucked in by earth. I feel comfortable walking, but imagine it is not that predictable. It's changing all the time. So Allah subhanahu wa ta'ala is merciful to make these things predictable. And so we can live comfortably. Therefore, when you are a Muslim, you should be religiously scientific as much as you can. No conflict between science and Islam. Thank you very much. Barakallah feekum. I love you all, like I said.